Here the question is to write the structures of monomers used for getting the given polymers. First one is nylon 6,6. This is a type of synthetic polymer, specifically a type of nylon known for its strength, rigidity and thermal resistance. It is made from hexamethylene diamine and adipic acid, and the reaction for their preparation can be represented as per the given equation. This nylon 6,6 is commonly used in textiles, automotive parts and industrial components due to its durability, resistance to wear and chemicals. The second one is given as glyptal. Glyptal is a type of synthetic resin, usually an alkyd resin. This is used mainly for coatings and paints, and it is known for its excellent adhesion, durability and resistance to environmental factors such as moisture and chemicals. They are prepared from two monomers. They are phthalic acid and ethylene glycol. The third one is given as Buna S. This is a type of synthetic rubber known as butadiene styrene rubber or SBR. This is used in various applications, primarily in tires and automotive components. Buna S is valued for its durability, abrasion resistance, and good aging properties. The combination of butadiene and styrene in Buna S provides enhanced performance in terms of elasticity and strength. Now let's come to the OR question. The first one is to identify the given polymer is a homopolymer or copolymer. The given polymer is a homopolymer because homopolymer is a type of polymer made from only one type of monomer. Here it contains only one type of monomer means this is an example for homopolymer. In the second question, we need to write the monomers of the given polymer. The given polymer can be synthesized from the monomer and the structure of the monomer can be represented as per the given diagram. And in the third question, we need to write the role of sulfur in vulcanization of rubber. Sulfur plays a crucial role in the vulcanization of rubber. This is a chemical process that involves adding sulfur to raw rubber to improve its properties. Sulfur forms cross links between the rubber molecules, which enhances the strength of the material, elasticity and durability. This process helps the rubber to maintain its shape and performance under various conditions, making it more suitable for applications like tires, seals and gaskets.